Welcome to the next video in the Oregon FFA Forestry Career Development Event Series. This time we're shifting to compass and pacing. While these tools have been around for a long time, they remain essential in modern forestry. We'll cover how to accurately set and use an azimuth compass, how to determine your pace, and how to use it to measure distances. We'll then go over what is expected during the career development event. Let's get started.
I'm Jerry Risk. I'm a forester with Roseburg Forest Products. When we're laying out harvest units, we try to make our units as geometrical as possible, so straight lines. And a lot of times what that means is having to run a bearing with a compass. And so we'll shoot a bearing from the top of the landing all the way down the hill. And as we're going down there, we're using GPS as well to drop points, to maintain that bearing, and also reference it with our compass to make sure we're on the straight bearing to keep it as straight as possible. Technology has definitely replaced a lot of scenarios where you may need to use your pace, but your phone battery will die sometimes. And so it's very, very important to still understand what a chain is, what your pace is, how many chains between plots. So all of the old school methodology of understanding pacing and chains is still very much in play in the forest management sector. Career opportunities and pathways right out of high school would include working in a manufacturing facility or even on a logging crew, which are great opportunities and great experiences to learn more about how the logs make it to the mill, and then what happens to those logs when they get to the mill. From a forestry management standpoint, we look for individuals who have a 4-year degree in natural resources or forest management related career or area. And we are fortunate to have Oregon State University in Corvallis, which is one of the best forestry schools in the nation.
Let's start with how to use an azimuth compass. The first thing to understand is that a standard compass doesn't point to true north, the geographic North Pole. It points to magnetic north, which is located in the Arctic, but not at the same spot as true north. In fact, magnetic north moves. Over the past 500 years, it has shifted across northern Canada and is currently moving towards Siberia at a rate of approximately 30 to 40 miles per year as the Earth's iron core shifts. To ensure accuracy, we adjust our azimuth compass by setting the declination, which is the difference between magnetic north and true north. Declination varies depending on where you are on the planet. You can find the declination for your exact location using resources like the National Oceanic and Atmospheric Administration (NOAA) website, which provides it based on your coordinates or address. Declination is also often shown on maps, usually in the legend, so you can set your compass accordingly. On an azimuth compass, setting declination is simple. Flip the compass over and use the small key attached to the lanyard to turn the tiny brass screw in the black ring. As you turn the screw, the black tail inside the compass moves along a graduated scale. One side of the scale is marked east declination, the other west declination. Adjust the tail accordingly to set your compass to the correct azimuth for your location. After setting the declination, you're ready to use your compass. When we shoot a bearing, or azimuth, we're not just checking north, south, or west. We're working with precise degrees. Since a circle has 360 degrees, with 0 as north and 180 as south, we can lay out a highly accurate bearing line. To do this, rotate the black disc on the compass until it aligns with the needle, which points to magnetic north. The compass has a sight on the top lid that helps you take precise readings. Hold the compass at eye level and adjust the mirror to about a 45-degree angle. This lets you see the dial clearly while sighting your target, so you can ensure the red needle is properly aligned with the red arrow for an accurate bearing. A common nickname for this step is putting red in the shed, because the red arrow on the dial looks like a little house when viewed straight on. By turning the dial to line up the red needle with the red arrow, pointing to magnetic north, you get your most accurate bearing. Then, read the bearing at the top indicator to see your exact azimuth. Remember, the graduations on this circle is often by 2s. One important note: accuracy with the azimuth compass depends not just on sighting carefully through the notch, but also on standing in the correct spot. Even being a few feet off from the intended starting point can give a different reading than someone a few yards to the left or right. Always make sure you're lined up precisely from one point to the next. Now that we understand how a compass works, let's talk about pacing. Pacing is a simple yet effective way to measure the distance between 2 points, especially when those points are hundreds of feet apart, where using a tape measure would be impractical. Pacing is much quicker when extreme accuracy isn't required. The first step is to determine your pace. To find your pace, start by laying out a measured 100-foot distance. Walk the length at your normal, comfortable stride, counting each step as you go. Record the total number of steps it took. Next, calculate how many feet you cover per step by dividing 100 by your number of steps. In other words, 100 feet divided by the number of your steps to get feet per step, which you can use to estimate distances in the field. Now that we know how many feet we cover per step, pacing a distance is easy. Start at one end of the area, count your steps as you walk, and stop at the other end. Then, multiply your total number of steps by your feet per step to calculate the distance you've traveled. To improve the accuracy and consistency of your pace, start walking a few steps before the starting point so you hit it in stride, and continue past the end point without breaking your rhythm. This avoids the shorter or uneven steps we often take at the beginning and end. Also, remember that walking uphill or downhill can affect your stride length. One more important note. When learning, we often compare our results to others. But remember, everyone has their own pace. For example, one person might walk a distance in 59 steps, and at 1.9 feet per step, they would calculate it out and get 112 feet. Another person might walk the same distance in 51 steps, but they've already figured out that they walk 2.2 feet per step, so when they multiply it out, they'll also get 112 feet. It's okay to have different step counts from another person, as long as you're consistent and accurate in calculating the final distance. In the Forestry CDE, compass and pacing are done together on the same answer sheet. You'll follow a 5-point course with points labeled 1 through 5. On your sheet, you'll record the azimuth and distance between each pair of points, 1 to 2, 2 to 3, 3 to 4, 4 to 5, and finally 5 back to 1. You don't have to start with 1, but you should complete all of them, and be careful where you record it. This practicum is completed at the same time as the map reading practicum, with a total of 40 minutes to complete both. A couple of other things to remember. The declination for the CDE location is printed on the answer sheet. In this example, it's set to 20 degrees east. It might be a provided number and not necessarily accurate. Make sure your compass is adjusted according to the page. When recording distances, round the nearest whole number using standard rounding rules, as noted on the page. Finally, as the CDE can get busy, be sure to line up as close as possible to each point when shooting your bearings. Don't stand off to the side, as even a small misalignment can affect your accuracy. In our next video, we'll go over the finer details and key points of map reading.